Okay, we will continue our discussion on the eye of math and guide out to of mathematics from 1 to infinity. Today we will discuss about calculus, and which is studies derivatives. Okay, like slopes, derivative can be positive or negative or zero, as indicating whether something is rising or falling, rounding up. Consider Michael Jordan flying through the air before making one of his thunderous just after letter is vertical velocity, the rate at which its elevation changes in time. Thus, another derivative is positive because it is going up. Its elevation is increasing. On the way down, this derivative is negative. At the highest point in jump, where it seems to hang in the air, its elevation is momentarily unchanging, and the derivative is zero. In that sense, it is truly hanging. And this concept of changing derivative positive to negative where it becomes zero is important in calculus. Okay? It is repeatedly used. So he explains it with another context. The problem is like this. My high school teacher, one day he came bounding into class and began telling us about his hike through a snow-covered field. The wind had apparently blown a lot of snow across the field, blanketing it heavily, forcing him to walk much more slowly there, while the rest of the field was clear, allowing him to stride through easily. In a situation like this, he wondered what path a hiker should take to get from point A to point B as quickly as possible. One would have thought it would be drive straight across the deep snow to cut down on the slowest part of it. Okay, that means first you walk directly the snow straight so that the distance is less in snow. Okay, or you go by a straight line from A to B, or it may be a different point. Okay, the idea is which point is meeting point, the crossover point. See, to minimize distance in snow, you can go straight and then walk longer distance in the normal field, or you can go the straight path, or you can choose some other point to change from snow to field. So with different algorithm, you find the best path. It is a certain specific compromise between the two paths considered above. Okay. Okay, we want to minimize the time. So he says that what you do here actually it is something like this. The analysis involves 4 main steps. First, notice that the total time of travel. So you try to plot a curve between total travel time between the different x distance where it changes from snow to the field. The x, okay. See, first notice that the total time of travel, which is we are trying to minimize, depends on where the hiker emerges from the snow. He could choose to emerge anywhere, so let us consider all possible exit points. Each of these locations can characterize successfully by specifying a single but the distance x where the x emerges from the snow. So when you give a graph like this, the point where the rate changes from positive, negative to positive. Okay, further find the lowest point. We invoke the zero derivative and so on. Through that, we calculate the derivative, set it is equal and solve for x. This is an important technique.